Hi guys, old man Chris in the shop. The following video is a little different, I suppose. I might call it Bits-10 actually. It only covers three things mainly. I gave a bit more description of my cross-slide stop, which a couple of people had asked about. And the other two things I've actually shown before briefly, and you'll see what they are when we get to them. And this is a bit of a cheat, I suppose. Without seeking any great sympathy, and I'm not after that, I'm just explaining, my back has taken a turn for the worse this last week. Really not good at all. And at my age, I sort of tend to think, is it ever likely to get better? I'm hoping it'll improve, but time out here for standing, very limited. I don't feel like getting onto something long term, not yet anyway. And then the usual thing, temperature. I know, I always go on about the weather. But it's 90 outside, very humid. In here isn't too bad at 75, but it's progressing, makes it a bit harder to spend a long time. Anyway, we'll see how things are in a week or two. So if I don't get anything out for a bit longer than usual, that's why. And I hope what follows may be of interest to some. And I'll probably not bother with a finishing section. Once we get to the end, that'll be it. So I'll say for now, if you've got to the end, or get to the end, thanks for watching. Thanks to all my subscribers. Take care, y'all. Bye. One or two people have asked about my cross-slide stop, and I'm not going to take it apart as such. I'll just describe one or two things. It's going to be very specific to a particular lathe. Now, on here we've got two threaded holes at the back which can take the taper turning attachment, and I rarely use that, to be honest. If I did use it, I'd have to take this off. But all this is, I'm going to see. Oh, I'll have to zoom in a bit closer. I'll try that again in a moment. All it is here, we've got two spacers. We've got a piece of plate which is about inch by 3/8, and that's been cut to give this top section. And at the back there's a piece of 3/4 square which is bolted onto it. The two pieces are then bored out for a 1/2 inch, or bored and reamed, and this is a piece of 1/2 inch rod. And then this, let me come in closer. Alright, I don't know whether I can see this to get it set up. No idea. No idea. I'm trying to, oh yes, there you are, I think. You can see there are two cap screws in the 3/4 square, and above that is the 1/2 inch rod. Can you see that? I won't zoom in anymore, I might lose focus. But how that's attached is academic. The main thing is to have a bolt-on block with a through hole for a piece of rod, and then some means of locking. Now the locking could be anything. It just so happens that I set up this piece of 90-degree bent 1/4 inch. No, it isn't, it's 5/16 I think. That's threaded through for locking onto the rod. Now if I take the, I've already unscrewed this, that's the chip cover. So you can see the lead screw in there. Now that bolt holds the brass nut. So what happens is, and this is still quite a good tight fit, right, that is now set up. The height, of course, is to suit a suitable place on the nut. If I bring the cross slider across, what I can do then is lock that, and I come back, and then it stops. Undo this, go forward further, lock it up again. We've now got a new position. Stop. Now what I use this for most, and I find it invaluable, if I'm threading, and by using an indicator first of course, set 0 for your relief, shall we say. Wait a minute. Let's get that. Let's redo that. All right, let's get this right here. That stop point can be my carriage stop when I'm threading. So we can run a thread pass. We're using the compound, and I'll usually have an indicator on that. So when we've taken a pass, come back, come off the thread, go back, change the compound by whatever cut, then we take another thread pass, back off, come back in. So that's coming back to a 0 every time. It saves using a dial, and then everything is obviously done with the compound. Occasionally this is useful for other purposes. If you want to stop a cut on this direction, that basically is it. Just to recap, 2 spacers, 3/8 by inch bar, which is cut into a relief so that the top part takes the stop rod and then fixed to the back by whatever means convenient, bored through, and then we've got the movable rod. Okay, that's just basically all there is to it. Any questions on it, specifics, you can always ask me. Well guys, this is something I've covered before actually, but I'm going into it again, trying from a different viewpoint. This will be of interest only probably to those who plink and shoot with 22s. Might be of interest to Harold from one aspect, which I'll cover in a minute. This is a device made by Paco Kelly, P-A-C-O-K-E-L-L-Y, and a web search will bring up plenty of info on it. This is a very early model. There are since I think another 2 versions with multiple holes, so you can do more stuff at once. But the idea is to reform the lead bullet. And you've got this plunger, shall we call it? You got this one, and this one. The idea being that you put, there are 2 ends here, there's about 2 thou difference, about 2 thou difference if I remember. Sorry, I keep going out of frame now. I'm putting this in the looser end, and using this this one first. This just flattens. Now the easiest way to use this is on a firm base and you hit with a hammer, but I have a better system. Let's come back a bit. I've got a very precarious mount for the camera, but I'm trying to get overhead here. Instead of using a hammer to form one of these, I'll show you a typical example. This is one that was done before, and if that'll focus, you can see that this was a round nose and it's now had a flattened front end. This makes it a very good wad cutter, and you get a much cleaner hole when you're target shooting. Instead of the ragged hole from a round nose, you get a fairly good punched hole. Now this contraption here I made quite a long time ago. Got a piece of plate at the bottom which is 1/2 inch plate, and it's about 2 by 4.5. Top end is just a convenient chunk of 1 by 1.5 by whatever that is, 4 inch, and that's to act as a weight. And now this is where it might get tricky. We've got 2 parallel rods there for sliding. I don't know what's going to happen with focus at the moment. Hang on a minute, it's come off. Let me bring that. I'm trying to give you a top end view. This piece of aluminum here is just a means of holding it at the top. Alright, that's all it is. It was a last minute thing I added, which means I can come up to the top, slide it, and it stays up. So there's the prepared situation. We've got the round's fallen out. We've got the round pressed into the bottom, and then here there's a very slight rebate hole which you might be able to see. We place that on top, and at the fullest throw, which I've graduated here, 0 to 9, and that has dropped the full height. If we push that out, we've got the maximized wad cutter. Alright, quite some time ago I made this test set, and it's using drop heights from basically 1 through 9. So we've got a small indent, progressively greater, and then we get to the max. And as I said before, that makes a very good wad cutter for target shooting. Now if you're into varmint hunting, let's take, these are all rounds that didn't go off, and that piece down here, by the way, if that's even in focus, is padded. So some may think, well, if this was a live round, this one didn't go off. If you've got a live round, you don't want to be hitting the base, but rimfire requires a very distinct impact on one spot. It's perfectly safe. If we use this pointy one, again I'm just doing full height drop. Take that out. It takes a bit of an effort to drive it out sometimes. And now we have a hollow point, quite a significant hollow point. Because this has been done in a carefully controlled bore in here, it will still chamber in your rifle. That makes quite a good round for varmint work. And then finally, if we use I think that one's he's called the nasty nose. And the other one here, which I think almost more deserves nasty nose, that produces a hollow point, but a different type. Right, let's do a drop. Now this one, take it out. That produces a hollow point but with a centre pin. And I don't think I've ever tried this one actually, but it's probably a bit nasty. So there you are, that's just a recap. I did this months and months and months ago, but I was doing it in my office actually, but I thought this would give a better view of the whole thing. I've got writing on one side, here we are. This may not even be visible. These are, I think they're 1-inch graduations. So my maximum drop's 13.5 inch to the plate, and to the brass piece it's 11 inch. So I can go, basically I've got 9 graduations. The beauty of this is, depending how much you want, most of the time you use the whole drop. And you can get consistent results. You drop from the same point every time. And the final thing I didn't mention, the impact point on the top weight, it's a circle of rubber. It's just stuck on, piece of inner tube rubber. And that means that when you hit the brass, you don't deform anything. It's not like hitting with a steel hammer. Alright, so if there's any queries on that you can let me know, but if anybody interested shooting 22s and wants to experiment, look up Paco Kelly, and if you get one of these it'll give you a chance to do quite a bit of experimenting. Now here's something else I discussed once before. I think I only showed it briefly, but I thought I'd go into a little bit more detail. The reason being twofold. One is, this is a smoker, runs on diesel or kerosene, and we have a piece of wick in there going to the bottom for the fuel. The reason that I ever made it was partly an interesting challenge machining wise, but also occasionally I have found that smoking a part does much better than die-chem if you're going for fit. If you're testing the fit of a taper or something, if you light this you get a really yellow flame, lots of soot. You just waft it around all over the surface you're interested in and then do your test. Very useful. But from a machining point of view, I thought it might be of interest to look at it just in a bit more detail, because for anybody who's perhaps starting off with machining, it's a very useful exercise for threading. So we've got the base, alright, that's bored out, that's your fuel container, and we've got the top, which has the sort of nozzle through hole for the wick, and then a cap which you put on to keep everything together and keep your fuel in. Now firstly, threading. I don't know whether this will show. You may just have to take my word for it. If I put a thread gauge on here, this may be out of focus, I don't know, I'm trying to keep focus tight, but anyway, that is 26 TPI. One of those situations where I wanted a fine thread, and I've over the years picked 26, whatever the diameter, because it's very nice for a fine thread. So what was done, I think we started off, the material was 1.25 inch I believe, and it was turned down, and in each case we kept an extra band to add some fine knurling. Then the male thread, no, I beg your pardon, the female thread was done, and this was calculated out to match male and female, plus we got some O-rings to do. But first of all we made the female thread using some math to work out approximately what was needed relative to the thickness of the material. Then the male thread, and doing it this way you were able to finish the male thread such that it would actually go together. Alright, so male-female threading like that's quite a challenge. It can be done entirely mathematically, but when you're doing it by hand on a machine there's an element of try it out, see if it fits. And if I remember rightly, in all cases I would do the internal thread first, get that right, cutting to depth according to what 26 would require, and then make the male and oh, trying to get it back together now. Trying to get the male thread right so you fit it nicely. There's no slop there, no slop to speak of. And the other thing, I may have to come in a bit close for this, bear with me. I think we're still in focus as far as I can tell. So there's the tank, fuel tank, and you might be able to see, if I've got something to point with, you might be able to see here I made a form tool, if I remember rightly, round nose. Made a groove there, and then also in the next piece made a groove there to seat on the O-ring, and then also cut another groove inside there. So if I put the O-rings back on, this might be tricky trying to stay focused. I apologise if I keep going out of frame, but I'm almost a bit too close for comfort. And I put that one back inside. This fuel tank aspect is double O-ring. The idea being to seal. Hang on a minute, I've got to look what I'm doing here. This does go in. It's not quite the best size O-ring, but it's the one that I used. Let's try and push that in. Alright, that's basically there. So we've now got a surface here to bear against the internal O-ring, and we've got this surface to bear against the outer. I'll put that together. And when it's tightened up, the O-ring, or both, the inner one as well in theory, are both sealing. But of course fuel can still come out of the top. But with a wick in it, and the wick that's here is actually not quite thick enough. I'll put that in a minute. But just to finish, here's the top section. We again have an O-ring groove. Try and put that O-ring back on. I'm really running in ridiculously close on this, and focus is super critical. There's that O-ring back on, and again a receiving groove for the O-ring in the top. I'm trying to see what I'm doing on the camera viewfinder, which makes it a bit tricky. And that's done up. That in theory is fuel tight. With a very slack wick, if it falls over you're going to get fuel in the top, but in theory you could carry that in your pocket. Let me zoom back a bit. Now I'm just going to put this back as it would be in use. And I don't know whether I can get the try and get the wick through. This might be a bit difficult. Try and wet it a bit. There we go. So this end would go into the tank with a slight coil, and then this part, I say this is a bit thin for a wick. This part would be probably about there, and you get a nice 3/4, half-inch 3/4 flame. Alright, so I'm repeating myself up to a point because I did mention this long ago when I was showing things made years ago. This actually did get a bit of corrosion from storage, and it's not quite as clean as it used to be. I don't know whether might be able to read the bottom. I used to be called Polytask, 1991. So there it is, a soot smoker. But anyway, apart from its utility value, making smoke for testing fit, a very nice type of test for somebody who wants to practice their threading. Let me just give you the dimensions, and there's no reason why anybody should make exactly the same at all. But that is basically 1.5 inches, that's 3/4, and that section's 7/8. And I say it started life from a piece of 1.25 inches. So that's it. Nothing being made, but just showing you how it was put together, and as I say, with matching threads, making O-ring grooves and stuff, quite an interesting project.